strain your back or your neck while listening to this lecture. Also, please again, stay alert of your entire surroundings, be alert and aware while participating. So thank you, everyone, and let's remember to always think safety first. Enjoy the session. Ellen, over to you.
Thank you very much, Helen, for such a safety moment. Ellen is back on the call, so she'll take over now. Ellen, please confirm you can hear me. Ellen, can you confirm you can hear me?
Yes, we can hear you.
Okay. All right. Okay, just while we're waiting for Ellen to come back on the call, I would like to recognize some very important people that have joined us here on this call. First, I would like to recognize the presence of our ambassador lecturer, the person of Mr. Faith Bamboy. Thank you, sir, for joining us on the call. I would also like to recognize the presence of our YP chair, one of the persons that made this program possible, the person of Mr. Lok Ememe. Please let's all give them a virtual round of applause. Ellen, please, are you ready? Are you good to go? Okay. While we're still waiting for Eric, I would like to also recognize the presence of some key people that have still joined us on this call. My colleague for Ambassador Lecture Program is on the call, the person of Ms. Ebby Bobomi. You're welcome. I would also like to appreciate all our collaborating chapters today. UMass, Western Delta University, and AUST. Thank you very much for joining us in this collaboration. Ellie, if you can hear me, kindly unmute and go ahead.
Okay, thank you very much, Juliana. Thank you so much. I'm so sorry, everyone. So I was lost for a while, and I'm back now, strong and fit. So thank you very much. Okay, and thank you so much, Miss Naki, for the safety moment. So we'll go to the next agenda for today, and that will be our opening remarks. And our opening remarks will be handled by a very big person, a senior professor, Engineer Christopher Iguatu, FNSE Award Chairman, SPE Wari Section. Sir, please kindly confirm if you can hear me. Hello, Engineer Christopher, please kindly confirm if you can hear me. Okay, Juliana, kindly please confirm if you can hear me. I don't know if I'm having issues.
Yes, okay. I can hear.
Okay, thank you very much.
Yes,
please.
You can hear me now?
Yes, sir.
Okay, all right.
Thank you very much.
And good evening to this presentation. I'm glad to be on the call. And I also want to acknowledge the organizers for putting this together. Okay. I can remember in my days when I was in YP, or when I was a YP, I also had the privilege of serving as a YP chair. And that was when I really enjoyed SPE. You know, I was utilizing my energy positively, and it looks as if I will remain a YP forever. So I want to encourage all of you that are YPs now to ensure that you utilize your energy positively and try and see how you can grow your career, you know, leveraging on SPE membership. Okay, so coming to today's presentation, well completion 101, how wells are made to produce. The presenter, Fit Bambuye, is someone I know very well, and I know he's going to do justice to the topic. So I want to encourage you to ensure your pen and paper is with you, and don't leave the webinar without filling up your paper. I cannot let the cat out of the bag, but I know he's seasoned, he's experienced. I know he's going to dwell into the critical steps that turned a drilling well into a producing asset. Okay, I know he's going to touch topics like casing and cementing techniques, okay, to ensure well integrity. Is going to take you through perforation methods to assess the reservoir. He's also going to talk on a completion string design and installation for optimal flow. He will look at stimulation techniques, like hydraulic fracturing and acidizing. We'll also look at production testing and optimizing strategies. Yeah, so elaborating a bit, casing and cementing, and just talking about the casing, there are steel pipes, how they are inserted into the wellbore, and you also look at the process of cementing, so that how you can cement the casing, put them in place to stabilize the well and isolate formations. Then looking at perforation, how the casings are perforated at the target zone to allow hydrocarbons to flow into the well. Then it will also dwell into completion string, a production turbine and packer system, So we'll also look at how the completion strings are installed to control fluid flow and isolate the reservoir. We'll look at simulation techniques, like I said earlier, hydraulic fracturing and acidizing, and how they enhance reservoir permeability. Talk about the wellhead equipment, the Christmas tree, the valves, the subsurface control valves, surface control valves, how they are operated, even the manual control valves, the check valves, how they are installed to ensure that flow is controlled. Then production testing, very necessary. You have to test your well. Okay, you test your well to evaluate performance and determine production rates. Like I said earlier, I don't want to let the cat out of the bag. And before I leave, I also want to advise you, try and write IWCF level 1. IWCF is the International Well Control Forum level 1. It's online, it's free. Okay, it's all about well control awareness, and it's gonna take you a long way if you really wanna have a career on well and asset performance. It's gonna take you a long way. Then since level 1 is free, you write level 1. Then from there you can continue 2, 3, 4. I think 4 is for supervisors and stuff like that. Okay, so I want to congratulate you for being on this class. A lot of people have been trying to understand well control or well completion, but they don't have the opportunity. So you are joining this class because you're a member of SPE. Don't take it for granted, okay? And ensure you make the best out of it. So thank you, everyone. Sit back, relax, enjoy your class. I also want to acknowledge the presence of the YP chair and other senior SP members of Section 104. We need to be coming around to encourage the young professionals. All right, thank you, everyone, and then back to you, moderator.
Thank you very much, Engineer Christopher. That was a very good one. Thank you for sharing. And we are hoping that at the end of the call or today's lecture, we will all be impacted with great knowledge. Thank you once again. Okay, so the next thing we are going to do is a very fun moment. And I'm really excited about this particular section. So we are going to have the icebreaker session, which will be handled by Mr. Emunumo Ogenekwarobo. He is the secretary for SPWDU chapter. Hello, again, please, if you can hear me, kindly confirm for me, please.
Yes, I can hear you.
Thank you very much. I'm hoping this session, as it is always fun, will be fun. So please, over to you. Thank you.
Good evening, everyone. My name is Emuno Morgan Eparugo, and I'll be guiding us through the icebreaker section on our topic, where completion 101, how well are made. So for this section, some words are going to be put out, which we're going to rearrange and help. We're going to arrange to make a word. So our first question is this. So this is how it goes. You're going to rearrange it to make a word and put it in the chat box. And let's see the answer. And the answer is reservoir. Mr. S. Severi got the answer. He was the first person who commented on the chat box. So the second question. And the answer for this one is perforation. So let me see. Yeah, Adoma got the answer correct. Perforation. So question number 3, we have and the answer for question number 3 is Parker. Cliff PTI got the question correct. Is the first person who commented on chat box. And question number 4.
Okay, I'm also going to come in a bit. All right, so question number 4, let's see. No one so far. Is this too difficult, or we just don't know? Myself, I'm just creating words in my head, which is very funny. Okay, we have from CPE telling us, Cliff, actually, a safety valve downhole. Okay, from Adoma Efriye, downhole valve safety. Please, let's keep our answers coming. We have 2 responses from Cliff and Adoma. Let's keep our responses coming. Okay. Okay, and the answer is downhole safety valve. Okay. Again, please, yes, I will just be side assistant and all that. So yeah.
Okay. So Mr. Amos got the question correct. So
Yes.
question number 5.
Oh, this seems very tricky. Let's see who is coming. Amos is saying Christmas tree. Adoma Christmas tree. Cliff Christmas tree or Christmas tree. Seems to be obvious, huh? Myself, I really don't know, but we really have brilliant people on this call. great. Christmas tree indeed. So, again, please tell us who won for this.
Mr. Amos Akpoduma.
Amos, thank you. Congratulations. Okay. Do we still have more coming?
No. So we've come to the end of the icebreaker section. I'll be handing over to the next speaker.
Okay, great. Thank you very much, Mr. Oginek Parubo. That was very insightful. Honestly, I never had any of them correct, which is very sad. But all the same, we have great minds on this call, as I said, and thank you all for putting in your best. Please let's give a reaction for those who gave the right answers. Thank you very much. The rest of us, we can do better next time. Yes, thank you very much, Mr. Ogene. So the next thing on our agenda today is to take our introduction of guest speaker, which will be handled by a very gentleman, Mr. Okote Oriri, who is the head of Volunteers SPAUST chapter. Mr. Oriri, please, if you can hear me, kindly confirm.
Yeah, good evening.
Thank you very much.
All right, so
Okay, so please, over to you.
all right, thank you, moderator. Thank you, everyone, for joining us here today. We just had a wonderful icebreaker session from the secretary of SPE Western Delta University. On behalf of AUST, SPE chapter, we're glad we had this collaboration. My name is Okuti Orere. I'm the head of volunteers from SPE AUST chapter. So now we are going into the main event. I'd like to introduce our guest speaker for today, Engineer Faith Bamboe, who is a wells completion engineer at SLB. He has a bachelor's of engineering in petroleum engineering from the Federal University of Petroleum Resources, EFRUM, and he has experience in planning and execution of well completion operations across onshore and offshore environments. Engineer Faith, are you there?
Yes, I'm in.
All right. He will be the one, glad to have you here. He will be the one to take us the main event. Topic is well completion 101, how wells are made to produce. Engineer Faith, you have the floor.
All right. Good evening, everyone.
Good evening.
Standing on the existing protocols, I want to greet everyone on the call. Thank you for making time to join the ALP today. All right, without wasting much time, I'll just proceed to share my screen. Please, once you see my screen, just give me a thumbs up. Yeah. All right. Okay, so the topic for this evening is well completion 101. I called it 101 because we are going to be looking at the basics of well completion. When you hear the well completion, what well completion is, you should be able, to break it down to its simplest terms, right? And Engineer Chris already gave an overview of what we're going to be discussing this evening, and it really did justice to that. Okay, so for our agenda, we'll be looking at the life cycle of a well. What is well completion, completion environment and constraints, completion types, main completion components. We'll look at the workflow of completion to production, why completion matters. Then we'll look at some key takeaways. Then we'll have some time for question and answers. So for the life cycle of a well, basically when you hear about oil and gas wells, before it comes into actualization, it has gone through a couple of phases. The major phases are what we see on the screen. We have the planning phase, the drilling phase, the completion phase, which we're going to be talking about, then the production phase, and during the life of the well, you want to do some intervention, and when it comes to the end of the life cycle, you want to abandon the well. So what we will be dwelling mostly on today is completion. And before you can complete a well, you have to drill it. You have to punch a hole in the ground to the desired depth, and you want to access the hydrocarbons that are deep down in the subsurface. But and before all of this starts, the design phase, the planning stage is very important, because whatever you put in your plan is what you want to work with, and you want to actualize the objective of the well. All right. So what is well completion? In its basic terms, well completion just represents, an interface between your reservoir and the surface production facility. When I say reservoir refers to that substructure in the down in the earth crust, thousands of feet in the subsurface, that contains the hydrocarbon, either gas or oil. So there's some specific properties that makes a particular rock a reservoir. I don't want to, delve into that, but once you hear reservoir in oil and gas, what comes to mind is that subsurface storage tank where you have the accumulation of the oil and gas. All right, why the surface production facilities just refers to the several components, equipment that work together in tandem to, process the oil and gas that you have produced from the well. So everything installed to allow hydrocarbons to flow safely and efficiently from the reservoir to the surface is what we call well completion. So it's involves the design, the selection, and installation of tubulars, tools and equipment located in the wellbore for the purpose of, conveying, pumping, and controlling the production or injection fluid. So what I mean by production means you are flowing the well or the reservoir fluid from the reservoir to surface. But when we talk about injection, you are injecting fluid from surface into the reservoir. That's another aspect of oil and gas. Okay. Then what well completion is not. So it's important to know that well completion is not reservoir engineering. Reservoir engineering focuses on understanding and, managing the oil and gas reserves that you have in the formation in the reservoir. With reservoir engineering, you are able to determine the volume of what you have there, how you can safely produce it, and then, you want to be able to extend the life of the reservoir. That's what reservoir engineering deals with. And drilling mechanics just involves the engineering and the physics application that are involved in drilling the oil well itself. And the facility design, like I mentioned earlier, are the equipment that you have on surface, to process your oil and gas into finished products. So well completion is none of these things. So let's not confuse them. So the importance of well completions include to provide a flow path for production or injection. Like I said, you either want to flow the fluid from the subsurface to surface, or you want to pump certain fluid from surface into the subsurface. An example of injection is gas injection or water injection. So what water injection or gas injection means is that the reservoir is not able to, produce all the fluids that are in it. So you want to assist the reservoir by pumping some fluids from another well just to sweep what you have there, to surface. So that's what injection basically means. And for new technology, advancement in technologies for carbon storage, we have some locations where they inject carbon dioxide, CO2, and store it in depleted reservoirs. So that's also injection. Another function of well completion is zonal isolation for the reservoirs that we have in the subsurface. So it's not just one reservoir. You can have a field that consists of tens of reservoir in stacks. So most times we have operators who want to complete 3 zones, 2 zones, in fact 4 zones in a particular well. So well completion can help you achieve that. So we call that zonal isolation. And then for pressure control, because these oil and gas fluids are buried deep down in the subsurface, over time, they have these innate pressure or stored pressure, right? You don't want all of that pressure to come to surface on its own. It's going to be disastrous. So well completion would help to manage the pressure and make the well safe for operation. And well completion would also provide future access to the well. Say the well is not producing as you expect, you want to do some form of intervention. Well completion provides you the conduit, the access into the well to ensure that the well is producing optimally. So we look at the completion environments and some constraints that are involved in well completion. And it's important to know that there are different environments, right, for oil and gas well. You have land locations, which is basically onshore. You have deep water, you have swamp locations, and then you have shallow waters. So for these different locations, the type of completion design that you do would differ from each other. For deep water, you want to do a type of completion that, would minimize intervention in the future because deep water operations are very expensive, right? So, first thing that we're going to look at here is high pressure, high temperature. And when we talk about high pressure, high temperature, you are looking at pressure regimes that are over 10,000 psi and temperatures that are over 300 degrees Fahrenheit. So those are high temperature zones. So the type of materials that you're going to use in that well is going to be different from a well whose pressure regime is less than 5,000 psi. And I mentioned deep water already. Deep water refers to water depths that are greater than 1,500 feet. In such environments, you have hydrate formation risks. You want to limit the intervention access, and it also involves complex subsea equipment. Then for the reservoir rocks, you have different types of rock in the subsurface. You have shales, it could be coal beds or titan, carbonate rocks, consolidated reservoirs, or unconsolidated reservoirs. Then for production constraints, there's risk of hydrate formation, wax formations for oil wells. You have high flowing pressures that you want to use specific tubing grades for. Then artificial lift methods is also another limitation for a well completion. I would explain what artificially means in the next couple of slides. And for well orientation, a well can be vertical, 0 to 5 degrees. It could be deviated, 5 to 60 degrees, highly deviated wells, and you have horizontal wells that are 80 to 90 degrees and above. Mechanical constraint has to do with the tubulars, the metallurgy of the equipment that you have in the wellbore. And when well completion is being planned, you want to design the well in a cost-efficient manner without compromising the quality. So you have cases whereby you need to consider your cost, you need to do some trades-off just to achieve the objective of the well. And for safety, you want to ensure that the equipment that you are installing in the well can manage the pressure regime that you have in the well. And also for sour service. Sour service refers to when you have hydrogen sulfide as one of the components of your wellbore fluid. When you have it in large quantity, it can damage your production, your completion system. So you want to choose equipment, materials that can, that is fit for the conditions of the well. So basically, everything I've said is summarized into three. The reservoir properties, which has to do with the pressure, temperature, and then the fluid properties, which has to do with the content of your reservoir fluid, and then the completion elements, which is basically the quality of the equipment that you decide to put in the well. So for completion types, we can define them in three categories: wellbore and reservoir interface, producing zones, and production method. When we talk about wellbore reservoir interface, it's talking about what you have, how you access the reservoir. Remember, I said reservoir is just like that storage tank that contains the oil and gas that you want to access in the subsurface. So the way you access the reservoir is basically what we are talking about here. So there are different types, even more than this, but I've limited it to these five. You have barefoot. Barefoot means you drill into the reservoir and you leave it like that. You don't run any protection casing into the reservoir. You just want to flow the reservoir fluids as it is. So this is usually common for consolidated formation. When I say consolidated, I mean that the reservoir rock are very coherent. They don't, break or dissolve into sand while you are flowing the wells. So it's consolidated, and this is usually applicable for wells that are over 10,000 feet. To give a perspective to 10,000 feet, an average adult has a foot length of 1 feet. So you can picture how deep 10,000 feet is. So another type is pre-drilled or slotted liner. So here you drill into the reservoir. Just to give a pictorial representation, this yellow color here, these yellow colors that we have here kind of represent the reservoir. So you drill into the reservoir and you run in a slotted liner. Slotted liner is just like a piece of tubular equipment that you've drilled holes, like you've perforated on all sides. So here you want structural integrity. You don't want the wellbore to collapse on its own. So you run this liner in it just to keep the wellbore in place. Also applicable for consolidated formation. Then for a cemented and perforated liner or casing. So here you've drilled into the reservoir, you run casing into the reservoir to provide additional support to the wellbore. But before you can be able to access the reservoir fluid, you need to perforate the reservoir. So you run in guns. That's another part of the oil and gas industry on its own. You run in guns to, shoot into the reservoir to allow flow of fluid from the reservoir into the wellbore. And another case here is open hole sand control screens or gravel pack. Here, it's similar to the pre-drilled or slotted liner. You drill the reservoir, you don't run a casing. As you can see here, this gray color represents cement. So here the casing is cemented, but in this case, you don't have a casing across the reservoir. You run in the screen, and then it provides structural integrity and also prevents sand production into the wellbore. So that's what a sand control screen does. We'll see it on a couple of slides to come. And similar to that is the case of gravel pack or frac pack. Here you run in your casing, you perforate, you run in screens, then you pump gravel into the annulus of the, when I say annulus, I mean the space between the casing and the screen. So you pump gravel into it. What the gravel does is that it also prevents the production of sand from the formation, because as the fluid flows, you have the tendency of producing sand, and sand is very bad for your production system. Sand would compromise your completion in few years, less than the life cycle of the well, and then you have to go and do some interventions that are very expensive. That's why the decision that you make to complete the well is the type of design that you go for is very important, so that you don't compromise the integrity of the well in a short time. And the second category of classifying well completion is the producing zone. I mentioned earlier that reservoirs are not just one specific reservoirs in the subsurface. You can have multiples. There are some fields here in Nigeria that have up to 10 stacks, in fact, up to 40 stacks of reservoir. But most times you have clients that want to complete 2 zones, 1 zone, 3 zones, as many as possible. So each well completion design differs from one another. So the first image we have here just shows us that this is a single zone production. That is, you have just one perforation in the well bore. And this is where the reservoir fluid flows into the well and goes through the production tubing. But for a multiple zone reservoir or a production, you can have sets of perforation below at a particular depth, and then you have another one at a shallower depth. You can have up to 3, you can have up to 4, depending on the requirements or the objective of the well. So when you hear about single zone production, you are only producing from one specific reservoir. But when you have multiple zone, you have 2 or more reservoirs that you are producing from. Then moving to the last category, the production method. So the production method are 2 types. The first type is natural flowing wells, and the other type is artificial lift. Natural flowing means the energy of the reservoir is enough to push the reservoir fluid to surface. You don't need any pump, you don't need any artificial method to flow your fluid to surface. So the reservoir fluid flow on its own to surface because the pressure in the reservoir is enough to, push it to surface. So for the natural flowing, these red arrows just indicate that you have your reservoir fluid flowing into the well bore and it continues upward through your tubing then to surface. But when we talk about artificial lift means like an engineering method that you design to put in the well to enable you to flow that reservoir fluid to surface. So you make use of artificial lift method when the reservoir energy is no longer enough, because the time will come at the life of the well that the pressure in the reservoir is not enough to drive the reservoir fluid to surface. So you want to employ a gas lift method that is available to you. And bear in mind that you must have planned this artificial lift method at the design phase of the well. Otherwise, you will have to remove the existing completion and recomplete it with the artificial lift method. Some artificial lift methods that can be incorporated into the design at the initial stage include gas lift, as we can see here. So basically, you just need a gas lift mandrel and gas lift valve that has been planned into the design, and that would allow you to inject gas into the tubing. So you inject gas through the gas lift valve here, and the oil that has been accumulated in the tubing, you are able to lighten it up to allow it to flow to surface. So that's basically gas lift method. And another method we have here is electric submersible pump. In many cases, except a proper study has been done, this would also be planned at the initial stage of the well. So in this case, you have a submersible pump, just like you have submersible pump in your water wells, water bowl at home, right? You have a submersible pump in the well, and when the reservoir fluid is no longer enough to flow on its own, the pressure is no longer enough, you power on the pump and you are able to flow your fluid to surface. There's another method that is not common in Nigeria or not available in Nigeria, but you must have seen it in pictures, videos in United States or in the UK. It's Soccer Rod method. So basically it makes use of hydraulic system to be able, to flow the reservoir fluid to surface. This is similar to these boreholes that we have here in Nigeria. If you notice, these boreholes that governments do constructing local communities, the one that you manually control with your hand and you have water being pumped out of the bowl, right? It's similar to the operation is similar. That's for the Soccer. So basically these completion types in the industry is divided into two, lower and upper completion. So to do a recap, the well bore reservoir interface refers to lower completion because that's the part that interacts with your reservoir. And the part that interacts with the space above the reservoir, we call it upper completion. That consists of your tubings, your gas lift system, electric submersible pump. So when you hear lower and upper completions, so it refers to the well completion types. There are some wells that require you to just have upper completion equipments in the well. There are some wells that require you to have both lower and upper completion equipments in the well. All right, we'll look at some main completion components, the most common ones and most important ones. And the first one we have here is sound control screens. I mentioned earlier that these sound control screens are installed in the wellbore reservoir interface. So screen, just as it sounds, means it screens sand. So there are different sizes. Studies would have been done to analyze the size of sands that are liable to be produced from the reservoir, right? And what happened is you want to filter out those sands from the wellbore fluid. You don't want it in your completion string. So the screen basically helps you to, filter out the formation sand and also provides wellbore stability and is also useful for gravel park operations and stand-alone screen completion. So but basically, this is a picture of what the screen looks like, and this cutout that you have just shows you the internal design of what a screen is. So you have this mesh, just like you have mesh in your kitchen, you use it to sieve grains or food and anything. Just it works basically the same way. Screen off the sand and you are good to go. Okay, another component that is very vital is the surface control subsurface safety valve. We call it safety valve for short, SCSSV, and three major functions. Emergency well flow control when there is need to shut down the well, maybe due to damage to surface facility. You don't want spillage of oil and gas to surface. You trip off the safety valve and it closes. And with that, you prevent loss to the personnel, to the environment, and you don't just spill hydrocarbon to surface. And the secondary purpose is to assist with the planned shutting in of the well. You don't want production from the way you would have closed your valves on surface, then you close this safety valve that is downhole. So that's just basic function of safety valve. Another key component is packers. So packers are very, very vital in your completion. The first thing, the major function is that it helps you to isolate the annulus that is above and below the packer. So you remember when I mentioned the multiple zone production system, you need packers to be able to achieve that. So the packers helps you to isolate one zone from another so that both of them would not communicate, right? And then it's also provide anchorage for your completion equipment. All the equipment that we're going to talk about, the packer provides anchorage for them. And it also provides casing protection. Your casing is, if you are familiar with water wells in Nigeria, the casing is similar to rings that you put in water wells or the plastic pipe that you run in your water bowl. That is what casing is in oil and gas. So it protects the casing, the upper annulus of the casing, that is the part above the casing. Reservoir fluids can be corrosive, they can cause damage. And casing is not something you can replace easily. The moment your casing is compromised, you have to do some remedial work, casing patch, squeeze cementing to fix it. You don't want to go through all of that stress. So you put a packer to help protect that annular space above your producing zone. And this is a picture of what a type of packer looks like. There are different types of packers, different types. This is just one of them. And gas lift mandrates, like I mentioned earlier, you need gas lift mandrates to carry out gas lifts for artificial lift method, right? Gas lift, you need gas lift mandrates to do that. And this gas lift mandate, what they basically do is to provide a means for you to install your gas lift valves. So they have these pockets on their sides where you install gas lift valve that will allow you to inject gas into the tubing to assist your oil to flow to surface. Okay, then another component is sliding sleeve. Sliding sleeve is just like a I think another brand name is sliding side door, right? SSD. So basically what you have here are just flow path, but there's a sleeve on the inside that can be shift up to open or shift down to open. So what it basically does is that it allows the production of fluid from the space outside the tubing into the tubing. So it's just providing a flow path for your tubing and annulus, right? And there are other functions. You can also make use of it in multiple zone completion systems. You can use it to drain a tubing. Let's say it's time to abandon the well. You have fluids filled up in the tubing. You can open the SSD because it's at a deeper depth. You shift it open and you can drain the tubing. That's also another function of sliding sleeve, right? And another item that we have here is landing nipple. The landing nipple provides like an interface to receive devices like plugs, memory gauges, or choke. So basically what it does is it has a recess like a lock, or yeah, a recess that receives a lock. Let's say you don't want fluid flow from your well bore for some reasons, or you are done producing a lower zone and you want to produce a upper zone. You run in a plug and the plug sits here in the nipple profile and it prevents flow of fluid from the reservoir to surface. Okay, and you can also use it for memory gauges. Memory gauges, you run it there to record pressure and temperature of the well bore over a particular period of time. Okay, another vital equipment is permanent downhole gauge. Permanent downhole gauge is basically an electric device that helps you to, monitor your well bore. You want to record the pressure and temperature of the well over its life. You make use of permanent downhole gauge, but you don't just run the permanent downhole gauge. You run it on what we call solid gauge mandrel. So the solid gauge mandrel has a pocket. It's on this other slide. This is the solid gauge mandrel, yeah, and this is the gauge. So you can see the gauge installed on the solid gauge mandrel. So this serves as a carrier for the gauge. All right, and with the information, the data that you get from the well bore, you are able to predict the behavior of your well over time. The another piece of equipment is wireline re-entry guide. It's usually at the tail end of the completion. So there's an aspect of well operations that requires you to run, some tools into your tubing. So in any event where you run an equipment past the tailpipe of your tubing, you want to provide a means for that equipment to be able to come back up when you are pulling it out. So the shape of the wireline re-entry guide is designed in a way it's beveled on both inside and outside, that if your tool gets to hang over the edge, it can slide in. Assuming you have a 90-degree edge, like what we have here, you won't be able to pull out this particular tool, but because the interface is beveled, you are able to pull it out and it can easily slide off the tailpipe, right? So like I said, the wireline re-entry guide usually at the tail end of your completion spring. Okay, and we cannot talk about all the oil and all the well completion equipment without talking about tubings, because the tubings make up the 90% of your entire completion string. All the equipment that we've mentioned earlier will be made up to the production tubing, and it serves as a conduit, right, for your production fluid from the reservoir to surface. It's just like the water pipe that you run in your water bowl, right, to conduct the fluid to surface. And the common outside diameters, the ODs of these tubings include 238, 278, 3.5, and 4.5, right? And the metallurgy that you choose for your completion will be determined by the fluid properties, the reservoir properties, and the temperature and the pressure regime that you have in the well. So you want to be able to choose something that will last, that will stand the test of time, that will last for throughout the life cycle of the wells. Just to give us a perspective, we have some wells in Nigeria that have been drilled and have been producing as far back as 1968, 1970s, and they are still producing up to now. It tells you that the quality of materials that were used, that were installed in those wells back then, are still functioning and are in good condition. When you go to feeds, for many persons that are familiar with these companies, that Heritage or Emeteti locations, any MPDC locations, you know that most of these wells are old wells and they are still producing. Okay. And the final component we'll be talking about is Christmas tree. It's funny that it's called Christmas tree, right? But this name has been adopted as far back as maybe 50, 70 years ago, a long time ago. And what the Christmas tree basically does is that at the end of you deploying the completion string, you want to be able to direct your fluid flow. You want to be able to control your fluid flow from surface. And this Christmas tree consists of several valves, chokes on both sides, up and above. You have it ascending, and that's why it's called Christmas tree. You have a lot of valves and fittings that resembles the shape of a decorated pine tree, right? So it houses chokes and valves for pressure and rate control. It serves as an interface between your wellbore and the production facility. And when it's time to access the well for intervention, it also provides a means of doing that safely. So this is what a typical Christmas tree looks like. So the Christmas tree is above the well head. The well head is on its own. Then the components that you have above the well head is Christmas tree. This is just a simplified diagram of the Christmas tree. There are much more different designs, a lot of designs, right? And like I said, this is a visualization of what completion is to production. So by the time you have run all the wellbore components, you've installed the Christmas tree, you can now open up the well and you flow the reservoir fluid from the reservoir into the wellbore. The packer keeps all the reservoir fluid within the wellbore interface, and then it flows through the tubing and then goes to surface through your Christmas tree and then goes to surface. So why, when you hear well completion, why does it matter? Why does completion matter? So just to give a perspective, the picture you have here on the right is also a type of Christmas tree. So these larger components you have here is the well head, and this part above is Christmas tree. So why does completion matters? It helps you to unlock your reservoir value. That is, you are able to efficiently and safely produce your hydrocarbon to surface. It would enhance the safety and integrity. Integrity in the sense that when you choose the right completion tools, you have the right engineering designs, you are able to efficiently, produce your reservoir fluid without compromising the environment, the personnel, or your surface equipment. Then it increases asset reliability. When you have the right design in your system, you reduce failures, you reduce uptime, and then you are able to, produce the well throughout its life cycle. Abi, you have your hands up. Please go ahead.
Yes, sir. I just wanted to tell you you have roughly around 2 minutes more.
Oh, yeah, we are already at the end of the presentation. All right. So, to wrap it up, completion matters because you want to be able to, manage your reservoir. You want to produce it over a long period of time, get your profit back at the end of the day. And when you choose the right completion design, the optimized completion, you are reducing the well cost in terms of intervention. When you do the wrong thing is when you tend to spend extra. You always come and fix one problem or the other. So key takeaways from this presentation is that completion is a system of tools, system of equipment that work together. It's not just one tool. A tool does not make up a completion system. So it consists of different components working together. And the choices of the completion equipment that you have in the wellbore will be driven by the conditions that you have in the reservoir, the fluid properties, and the availability of the equipment that you have, right? And the design you choose today will affect the entire life of the well. If the well is to produce for 20, 30 years, when you have the right design, the well will produce for that long. If you have the wrong design, you are shortening the life of the well. So that brings us to the end of the presentation, and we'll have a question and answer section. Yeah.
All right. Thank you very much, Mr. Faith, for that wonderful presentation. So we are just going to go over to the photograph session before the question and answer, right? So I would like to encourage every one of us to turn on your cameras, please, so that we'll get everyone captured. All right, so please let everyone turn on their camera. I'm trying to. All right. I see Miss Juliana. I see Okoti. I don't know if I pronounced correctly. Forgive me. Okay. I'm trying to see this view in a bigger space so that I'll capture. Yes, I have everyone on. I'm sorry my camera is not on. Unavoidably absent, sorry. But either ways, I'm just going to take this view I have here. So SB.
Solution people energy.
Yeah. So let me go over to the next. A lot of persons' camera is not on. What is it? Okay. I think I'll just take that. Okay, Carrington. Yeah, you're the only one on the second side. So yeah, I got that. Thank you, everyone. Thank you for showing us your beautiful and handsome faces. You can turn off your camera now while we move over to the question and answer session. And to do that will be Success from Western Delta University. Success, if you're on the call, kindly confirm you can hear me. Can I be heard?
Yes, we can hear you.
All right, thank you. Is Success on the call? Success, please confirm you can hear me. I'm going to do this one last time then. If she's not responding, I'll just take over. All right. Are you saying something?
Yes, it's not the call. You can go ahead.
All right, no problem. So at this point, I would like to see your questions. You can use the raise hand button if you want to speak. Then you can use the chat box if you want to comment. So let's have it. Let's have your questions rolling. We are going to be taking just questions, right? So any questions from anybody? Any question? It's like everybody understood what, okay. Yes, there's one question from Amos. I'm just going to read it out. 3 questions, actually. Okay, I said 2, but let's see how it goes. So yeah, the first one, it says, how do completion engineer determine the best completion type, either a single or a dual string? So Mr. Faith, please confirm you can see that.
Yes, I
I
got
don't
it.
know if, all right.
Okay, Do you want to read through the three questions or we take them one after the other?
Yeah, I'm just going to read. Since it's on the chat box, I think a lot of persons will see it. So the second question is, please walk us through tallying of completion strings and stick-up calculations. The third question, what does into completion planning and how completion engineers collaborate with drilling engineers? So I think he wants to know how the drilling engineer and the completion engineer collaborate for a completion planning. I think yes. So yes, that's it.
Okay.
Over to you, Mr. Pitt.
All right. So question 1 and 3 looks similar. So I'm going to take both questions together. So during the design phase of the well, that's even before drilling, all the teams, they all come together to plan the well. The geophysics guys, the geology guys, the reservoir engineering guys all come together, including the completion engineer, the drilling engineer. Everybody comes together with their ideas that are, by the industry standards, right, to design a well. So what we determine the completion type would, like we mentioned in the presentation, is controlled by three major things: the reservoir properties, the fluid properties, and also the availability of the equipment that you have. We have some operators that plan their wells 2 years, 1 year before they even proceed to drill the well. Whereas we have some that plan their well on the fly, right? And you have a lot of back and forth in the design phase, in the design of the well, even while it's being drilled. But the best thing is to plan the well and determine the design before you even drill. So what I'm basically trying to say is that it's not just the sole duty of the completion engineer to determine the best completion types. In fact, I forgot to mention the production engineer. They are also part of the team, right? So everybody come in with the design that needs to be achieved, and they agree on a particular one to go with. So if you're going to go with a single string and you want to produce, that means you only want to produce one zone. However, you can also produce two or more zones with single string, but that would also determine the specific equipment that you need to run in the way. This specific equipment includes the sliding sleeves, or if you want to go in the intelligent completion a portfolio, you want to consider flow control valves that you can control from surface with the use of control, hydraulic control line or electric signals. So the number of reservoirs that you have in the wellbore would also determine the number of reservoirs you want to access, would also determine the completion type that you want to install in the well. So most importantly, the completion engineer goes back with the discussions that have been made in the planning phase and go and select the equipment that will match the objective of the well. And then once those equipment have been designed, they are selected, the completion well bore has been designed, then they look for the service provider that can provide those equipment, right? And also deploy the equipment. And that's where SLB completions comes in, right? And every other service companies that also do the same in Nigeria. Then for the second question, this is a different scope that we cannot take on this call right now. But the basic idea of tally is that it consists of the measurement of your wellbore equipment, right, that you want to run into the well. So when your equipment arrive at the well side, your tubings are at the well side, you take measurement, you take the right measurement, right? And then you transfer it into a tabular format, Excel sheet, add up all the lengths and ensure that they fit into your wellbore. You cannot use a completion string that is longer than your well bore or shorter than your well bore. It has to be balanced. So maybe we can connect at a later time outside this call, and we can look at tally together, stick up calculations. Yeah. So I'm seeing another question here. How does wet stimulation, for example, acidizing, fracturing impact completion? So wet stimulation can be done before the completion is deployed, or can be done during the life of the well, same as fracturing. So we don't really do fracturing here in Nigeria because reservoirs have good properties in terms of porosity and permeability that allows the fluid to flow into the wellbore. So where you have fracturing prevalence is United States, where they have tight reservoirs. You want to open up the reservoir, you want to fracture it so that the fluids can easily flow into the wellbore. However, if there's need to fracture any formation in your completion design, there are sets of calculations, downhole hydraulics that needs to be done, and a particular service provider that has to do with pumping of the fluids and the propans that are needed would calculate the volumes that are needed, the pressure limitations, and all of that. So basically, what your acidizing and fracturing is doing is that you want to be able to produce more fluids from the reservoir. For example, for a perforate for perforations, your perforations can be dirty when you perforate them, maybe as a result of unclean completion fluid. So you want to perform acidizing to clean the perforation and also dissolve some of the unwanted I'll call it pollutants that you have in your wellbore reservoir interface. So that's what acidizing does. Why fracturing allows you to, open up the reservoir, open up more spaces in the reservoir to allow your fluid to flow in the wellbore. So at the end of the day, it would improve the condition of your well, in the sense that you tend to produce more. So what your question is trying to say, like, how does it impact completion? So how it impacts your completion is that whatever chemicals, whatever pressure regime you are working with has to be within the limitation of your completion design. You don't want to go to a higher pressure that would cause a damage to your completion string that would impact your completion string, right? So that's why it's important that whatever stimulation method that needs to be done has to be within the limitation of your completion design. That's if you've run the completion already. But if you haven't run the completion, then you can do the oxidizing, fracture the formation, then you run in all your completion. But ultimately, you want to produce more from the reservoir. That's why you are doing stimulation. I hope that answers all the questions.
That's nice. Thank you very much, Mr. Faith Bamboye. I'm sure they satisfied their curiosity already, but your response was very, explanatory. So we are going to, that's the last question. We're not taking any other question. Like I said before, we're going to treat Josh too. So thank you very much, Mr. Faith, for delivering. So I'm just going to move over to the next slide, which is the presentation of certificate, and that will be taken by Ms. Juliana Oche, the LP lead SP Worry Session 104. Ms. Juliana, please kindly unmute and present. Thank you.
Thanks very much for sending me my book. Thank you for stepping in. Confirm you can hear me.
Loud and clear.
All right, thank you very much. Thank you so much for such an insightful lecture. I would even want us all to call it welcome to 101. I would like us to call it maybe welcome to 500. 101 is what you do when you're another level or something. Thank you so much. All right. My wife Peter is on the call, and I would like to give you the honor to present the certificate to Mr. Lokemin. Go ahead. I don't know, he's still on the call. So, Loke, are you on the call?
Yeah, I'm trying to see if it's still here. No, I don't
Oh,
think it's on the call anymore. So
all
you,
right.
you can just go with you.
All right. On behalf of the section 1041, and our section chair, Dr. Jason Oluwaseun, and our YP chair, Mr. Lofty Emi, I would love to present the certificate of appreciation to our Ambassador Lecturer, Mr. Faith Bambo, in recognition for facilitating our Ambassador Lecture on well completion 501, how well and me. Thank you very much, sir, for taking your time and for delivering those exceptional results. This certificate will be mailed. Thank you very much, sir. And all right, over to you, moderator.
Thank you so much. Thank you, everyone.
Yeah, thank you. Thank you very much, Liana. So we're just going to move over to the next event on the agenda, which is please just move the slide. Yeah. Which is the Slido quiz, and this will be taken by William Oko, AYP from SP Warrior Section 104. William, can you confirm you can hear me? The floor is yours.
Yeah, thank you so much, moderator. Thank you, everyone, for joining. Yeah, welcome to an interesting session, segment of this interesting program today. So it's the Slido quiz here. So we've paid attention, we've heard everything our facilitator has shared with us. So it's time for us to know what we know and what we do not know. So I've shared the joining link. I would like to see the number of participants. Yeah, I want to see massive participants so that we can participate in this interesting session as we'll be starting in the next 1 minute.
Okay, so just
So
to
check.
add, the exciting prizes for sale. So please join in. We have for the first third position. Please let's turn up. Thank you very much. Thank you.
The same link I shared with them that they've joined.
So please, let's all join in if you can.
Yeah, so I think we are having a good number of participants. So in the next 30 seconds, we'll comment.
I've seen someone's name as suspect. So come, to be serious. I'm not sure I can get it to the when it's so, but it's allowed though. It's allowed. Okay? Well done.
Okay, 1 minute. I think someone is struggling to join. Just give me 1 minute so that I can make sure this person has joined. All right. So, yeah, we'll be starting in about 3, 2, 1, 0. Our very first question. What best describes the main objective of a well completion? Is it first option, control communication? Is it improving drilling penetration rate or maintaining drilling fluid circulation or increase reservoir pressure? So what's the answer? All right, so 100% of participants took the first option. So yes, that's correct. And what's our leaderboard like? Carl is topping, Gabriel is second, and I is third. Okay, interesting. Let's go to the next question. Why is production tubing installed inside the casing in most wells? Why is production tubing installed inside the casing in most wells? Why is it installed in most wells? What do you think the answer is? So Most participants took option 2. What does slide say? 2 is correct, and we have Carl still topping, suspect second, and IS third. So that is an overturn. Let us see. Our next question, what is the most accurate and primary function of a packer in a completed well? Yeah, most accurate and primary function. They may all seem correct, but which is the most accurate and primary function of a packer? What do we take? Our pick is option 3. Let's see, option 3 is correct. And what's the answer? All right, so our leaderboard has been, people have been displaced. We have your daddy coming into third place. Okay, let's go to the next question. Thank you. Why are perforations created in the casing during well completion? I think this is a bonus question. So why are perforations created in the casing during well completion? Why are perforations created in the casing during well completion? Our answer is, so most people took option 2. And is option 2 correct? Oh, yes, it is. Carl is still top, suspect, and your daddy following. Under which condition is artificial lift most likely required in a producing well? All right. I think our time is too much for the caliber of people I'm seeing here, yeah? Under which condition is artificial lift most likely required in a producing well? All right, so most people went for option 4. Is it correct? Oh, yes, it is. And our leaderboard, suspect is coming up top, Carl second, and your daddy third. Speed and accuracy. Thank you so much. What's the next one? What is the primary reason for installing sand control systems such as gravel packs or screens? All right. I think the facilitator did justice. Yep, so let's see. What's the answer? Most people went for option A. Is that correct? Oh, yes, it is. To prevent formation sand from entering the wellbore. All right. Suspect is up top. Your daddy second. Tinubu's son third. Carl has been displaced. Oh, beautiful. Let's go to the next one. What is the most important operational purpose of a subsurface safety valve? That's your SCSSV or your down-hole valve, as you say. Is it to regulate production flow rate, automatically isolate the wellbore in event of emergency, or isolate the wellbore in abnormal pressure conditions? What do you say? Most people went for option 2. Are you correct? Oh, yes, it is. Okay. What's the leaderboard like? Okay, suspect first, Tinubu son, and your daddy. Wow. Carl, where are you? Next question. What distinguishes intelligent well completions from conventional well completions? All right. I think our facilitator also pointed this out, right? So, what's the answer? Yeah, most people went for option 2. Is it correct? Oh, yes, it is. Our leaderboard. Interesting. Right, we have your daddy second and Tinubu son third. Speed and accuracy. Which flow meter type directly measures mass flow instead of volumetric flow? I brought this in so that we can cause a little bit of chaos. So please be able to enjoy this our little pandemonium now. So what's the correct answer? Oh yeah, many people felt this one. Our correct answer is the Coriolis meter. Thank you so much. Leaderboard, suspect first, your daddy second, and Tinubu son third. Interesting. In a differential pressure flow measurement system, flow rate is proportional to, according to Bernoulli's theorem, what is flow rate proportional to? This is where fluid mechanics come to play. All right, so, interesting. Square root of pressure difference, correct. And our leaderboard, your daddy finished up first, interesting. Suspects came second, and victory to Tinubu son. Wow, interesting. What a significant displacement. Thank you all for participating. Prizes for the first 3 winners. See you next time and enjoy the rest of your evening. Thank you very much.
Yeah. Thank you very much, William. That was really I don't know what to say, but it was very exciting. So, by the way, we have the next thing on the agenda. Please, can the slide be displayed? I would like to know who suspect was, because suspect and the other person, Tinubu's son, I don't know. But yeah, so let's see what we have next. So yes, we have the announcement coming up next, and that will be taken by Muhammad, the secretary of SP AUSC chapter. Muhammad, please confirm you're on the call and you can hear me. Can I still be heard?
Good evening, ma.
All
Good
right,
evening, ma. Good evening, ma.
The floor is
It's me,
yours.
Muhammad. All right. So, my name is Muhammad Anas. I am the secretary of this AUSC chapter, and I'll be presenting the announcements. So, what are these announcements? In this March technical lecture, there will be a BHP survey and estimation of fundamental reservoir and well performance parameters. Okay? And the speaker would be Engineer Dr. Okotie Sylvester. He is the reservoir engineer, or the MD consultant, KPML. He is a renowned author. He's also a master in reservoir engineering, and is also a first degree. He also got a first degree in petroleum engineering, which is a very outstanding thing. He will be the speaker for the event, which it will hold on Tuesday, 17th of March, 2026. The time taken will be 5:00 p.m. So we should take notes. We should not forget to attend this meeting. This is very important. The venue will be Zoom, of course. If you're having trouble accessing the link, you can simply scan this QR code so that you can easily join. And there'll also be the section chair, who is Dr. Adetona Oluwaseun. There'll also be the programs chair, who is Engineer Elvis Duroji. And then there will be the publicity chair, who is Dolapo Odeni. So this is going to be a very interactive event. Please don't miss out on this. You will love it. And then secondly here, there is this STSE 2026 that will be happening on the 26th of March to the 28th of March, 2026. STE stands for Students Technical Symposium and Exhibition. So, it's all about calendar, okay? You should know how to mark your calendar. You should mark your calendar. That is what I think they are trying to say here. The venue is PTI Conference Center in Warri, Delta State, Nigeria. And Francis Nwaoche will be the chair of the SP Nigeria Council. So,
all right,
I think that is all.
Mohammed.
Thank you so much for listening.
Thank you very much, Mohammed, for the announcement. At some point, I was like, it's NTA standard kind of like. But anyways, that was by the way. Thank you very much. So we have it, the membership drive. And the membership drive will be taken by Miss Ella Ortega Obo. I don't know if she's on the call. Please, Juliana, kindly confirm.
She's on the call, so I just go ahead and do it.
All right, so yes. Can I have the next slide, please? All right, so yeah. So SP Warri Section 104 is inviting you to be a member, to be a member of this professional association. Benefits of being a member of SPE. As we all know, SPE is the Society of Petroleum Engineers, right? So benefits are you will get a first-hand internship, and career information, mentorship programs from industry leaders, you have scholarships, you have training, you have access to our vast technical and professional resource library / knowledge base. You will get to network with professionals and industry leaders, both locally and internationally. And this is a cue to everyone on the call. If you're not yet a member, you can join. And if you're a member, but your membership is not in a current state, you can renew your membership and unlock hidden opportunities. There's a code on the slide that you could scan rather to join us. And I'll also be dropping the link on the chat box so that you can as well reach out. So thank you very much. That will be all for the membership drive. We'll just go over to the next agenda, which is going to be the closing remark, and it's going to be taken by Jude Alele, a YP from SP Warri Section. Mr. Jude, if you're on the call, kindly unmute so that we'll hear your voice.
Good day, everyone. Hope I'm audible enough.
Good day. Yes, we can hear you.
Okay, so first and foremost, I would like to thank everyone for making out time to be here. So on behalf of the SP Warri Section 104, the Young Professionals of Society of Petroleum Engineers, I would like to thank each and every one of you for making out time to be here. And without much ado, definitely want to give big appreciation to our speaker who did justice to the topic, Engineer Faith Bamboye. So when I saw the title of the lecture, it was more like 101. So for those of us who probably, I don't know how it is over there in Ghanaian institutions, what you see 101 is giving introduction vibes. But what we saw today went from 101 to 201, 301, 401. And then so really I must really thank him for schooling us through this. And I believe that a lot of persons must have learned one or two about work completion. And hopefully one day Engineer Faith will take us to the field so that we can have the practical experience, and maybe if we're very lucky, he can give us some of the fruits of the Christmas tree. So on that note, once again, thanks to our speaker and our moderator. You did a very fantastic job, and everyone who joined us here. Have a wonderful evening, and look forward to seeing you in our next ALP events and all of the other SP events that we have lined up for the month of March. Thank you so much.
Oh, and thank you very much, Mr. Jude. That was a very nice closing remark. I want to also thank each and every one of us for staying on the call since start till now. I want to also thank Engineer Christopher Igratu. As you can see, he's still on the call. So thank you very much, sir, for sticking around with us till this time. So yes, we'll call it a day here. Ms. Juliana, you have any last words? Kindly speak.
All right. Thank you very much, Ms. Becky. Thank you, Mr. Christopher. If you're still on this call, I want you to know that you are the MVP, was valuable person. Thank you so much. I would also like to appreciate my team members. This ALP did not just come out on its own. My team members worked tirelessly. Mr. Amos Apoduma, the content development of team, Mr. William Okon for creating such amazing video. My colleagues, we've been coordinating the three schools that we collaborated with. The three schools we collaborated with, NDU, UMass, and English. Thank you so much. Aboiwa, thank you for creating this amazing slide deck, Mr. Favor Ekion. Everyone, just thank you. Thank you very much. My team, carrying team, the publicity team, thank you. Together we can. Thank you very much. I wish you a great weekend and see you for our next video. Bye for now.
Bye. Bye. Bye.
Bye.